Hello, my name is Michael Wolf, and today I will be presenting exploratory data analysis and candidate time series models for flu surveillance data. This data was gathered from a program called FluView, which is run by the CDC in order to monitor and analyze flu data in the United States. We gathered this data from one laboratory for the months of October 2015 to February 2020. Additional information on FluView is available on this slide and at the link below. Looking at the realizations for this data, it's pretty clear we are likely dealing with non-stationary seasonal data, with each season occurring at roughly every 50 time points, or weeks in this case, starting at around the 25th week and peaking most strongly at the 125th week. This indicates a trend of probably every 50 to 52 weeks, or about a year. This also indicates that the mean is likely dependent on time and not constant throughout the series. The variance, there's not enough information on this graph to really say, but we can probably assume the same. Looking at the ACF plots, we can see that the autocorrelation. Finally, looking at the Parson window, we can see a strong peak at 0 indicating possible wandering behavior, although there are some very weak peaks at 0.29 and 0.45 indicating we may have a monthly seasonality, so we will need to examine this. Looking at our candidate models, our first candidate model was derived using an AIC process, and we fit an ARMA 6.4. As we noted, there was likely going to be complex conjugate roots, which we can see in the most dominant factor in this particular model. Looking at the forecasts, we see that there are pretty wide confidence intervals, and the forecasts regress towards the mean fairly quickly. We also have a fairly high ASE, indicating that this may not necessarily be the best model. We next wanted to explore a seasonal model. In order to stationarize the data, we took a first order difference and realized we still probably hadn't stationarized the data, so we fit a second order difference. Finally, we fit our second candidate model, which is an ARIMA 521 with a seasonal factor of 50. This model also has complex conjugate roots, although they aren't the most dominant factor. We also see similarly wide confidence intervals, although our forecast points seem to fit the data a lot more closely than our previous model. Though the ASE is considerably higher, the seasonality component might fit the data a little bit better, even with a less accurate forecast. Our third model candidate was an ARIMA 420 with S of 12. This model had even higher ASE and very wide confidence intervals. For this reason, this model likely isn't a strong candidate. Finally, we tested a signal plus noise and didn't find a deterministic signal. We don't consider a signal plus noise model to be a viable candidate at this point. Our next steps are to improve the confidence intervals and forecasting trends, and possibly introduce a multivariate or neural network model. Stay tuned for more information. Thank you.